If a projectile is fired with an initial velocity of v subscript 0 meters per second at an angle alpha above the horizontal and air resistance is assumed to be negligible, then its position after t seconds is given by the parametric equations, where x is equal to the velocity v subscript 0 times the cosine of alpha t, and y is equal to the velocity times the sine of alpha t minus 1/2 times gt squared, where g represents the acceleration due to gravity at 9.8 meters per second squared. Now, if the gun is fired with alpha is equal to 30 degrees and the velocity is 500 meters per second, when will the bullet hit the ground? And then how far from the gun will it hit the ground? And then what is the maximum height reached by the bullet? So for the first part, we need to rewrite them as parametric equations. So for the first part, we know that we have x, which is equal to the velocity times cosine alpha t. So that means we're going to substitute the velocity to be 500 multiplied by the cosine of alpha, which is 30 degrees, t. Well, we know that this becomes 500. Cosine of 30 is the square root of 3 over 2. So for x, we're going to get 250 times the square root of 3t. And now we need to look at the parametric equation for y. So y is going to equal the velocity times the sine of the alpha angle times t minus 1/2 of gravity t squared. So again, let's plug that in. So we have the velocity again is 500 meters per second times the sine of the square root, 500 times the sine of 30 degrees times t minus 1/2 times 9.8 t squared. So 100 times 1/2 t minus 1/2 of 9.8 is 4.9 t squared. So the parametric equation is going to be 250 t minus 4.9 t squared for y. So now there's a few things that we need to know. So whenever the gun is fired, so when the gun is fired, we know that at time t is equal to 0, then we know that x is going to equal 0 and y is equal to 0. So that means we have an ordered pair of 0, 0. Okay, and then when it hits the ground, we know that y is going to equal 0, but we need to figure out what is x. So we don't know what the value of x is, but we know that the value of y is 0. So if we know that y is 0, then we can plug it into y and solve for t. So we have 250 t minus 4.9 t squared, and then we're going to set that equal to 0. So we can factor out a t, and what's left is 250 minus 4.9 t, and set that equal to 0. So we know that we have one solution where t is equal to 0, and then another one where we have 250 minus 4.9 t, which is equal to 0. Subtract 250 to both sides, and then divide by 4.9. And so we get approximately 51 seconds. So if we know that t equals 51 seconds, when we know that when the y value is 0, meaning that it hits the ground, then we can determine the distance when will the bullet hit the ground, and how far from the gun will it hit the ground. So what we can do is, we know that it takes 51 seconds for the bullet to hit the ground. Now we need to know how far from the gun will it hit the ground. So we're going to plug it into the x. So x is going to equal 250 times the square root of 3 times 51 seconds. And so that is approximately 22,092 meters, which is approximately 22 kilometers. So that means it hits the ground at 22 kilometers. So here, just so that we can organize this here, so when will the bullet hit the ground? We know that it's in 51 seconds. Okay, how far from the gun will it hit the ground? Well, we know that it's going to do that in 22 kilometers. Now the last question is, what is the maximum height reached by the bullet? And so to find the maximum height reached by the bullet, what we need to do is, in order to find the maximum height, we need to use our vertex formula. And the reason why is because we're dealing with a quadratic. So we can figure out what is the maximum at a certain time. So we know that t is equal to negative b over 2a when we talk about our vertex formula. So what is negative b and what is a in our problem? Well, if we look at y equals 250t minus 4.9t squared, we know that the value of b in the quadratic equation is 250. So we have negative 250 divided by 2 times, well, the value of a is negative 4.9. And so that gives us approximately 25.5 seconds. And so now what we need to do is we need to substitute this into the function for y to determine the maximum height reached, since y represents the vertical distance. So y is going to equal 250 times the value of t, which is 25.5, minus 4.9 times 25.5 squared. So that is approximately 3,189 meters, or if we convert it to kilometers, then it would be 3.2 kilometers for the maximum height. So, in the last part of this question, we determined what is the maximum height reached by the bullet. Well, the maximum height was what we just found there. Okay, so now we want to use a graphing device to check our answers to part A, and then graph the path of the projectile for several other values of the angle alpha to see where it hits the ground, and then we're going to summarize our finding. So what we're going to do is we're going to graph our parametric equations into Desmos, so let's go ahead and do that. So we're going to put in our x coordinate, so we have 500 times the cosine of pi divided by 6, since that represents 30 degrees, and that's t times t. And then we have 500 times the sine of pi divided by 6, t minus 1/2 times 9.8 times t squared. And here is our graph. We're going to go, let's say, from 0. Let's just put in 30,000. Okay, so since we're putting in 30,000, okay, let's verify our results. So it said that it would hit the ground at 22,092 meters. So if you look here, it's going in a parabola, right? It's and it had a maximum. So here is where it hits the ground at approximately 22,092 meters. Okay, and it took 51 seconds. And then what was the height? Well, the height was 3,189 meters. So if we take a look at the top here, okay, for the maximum, it looks like it's in between here. It says 2,000 and 4,000. So the maximum is going to be approximately at 3,189. Okay. So now it says here that we want to graph the path of the projectile for several other values of the angle alpha to see where it hits the ground. Okay, so right now we did 30 degrees. Okay, so let's see what happens when, and let's see here, I'm going to put in, let's say, 50,000 here. Okay, so let's start at the smallest angle. So we're going to have pi and then divided by 12, which represents 15 degrees. So when it's 15 degrees, we can see that the height is a lot smaller and the distance is also a lot smaller because the distance ends up being in between 10,000 and 15,000. And the height is smaller. So that is at an angle of 15 degrees. Okay, well, let's change this to 30 degrees, which is what we saw earlier. So when we put in 30 degrees, this is what we got. We know that it landed at 22,000 and the height was at around 3,000. Okay, now let's try at an angle of 45 degrees. So that means we're going to take pi and divide it by 4. So there, now the angle is now at 45 degrees, which means now the distance is a lot further than what we saw in the previous one. So it's about a little further than 25,000, and the height now is above 5,000. Let's see if we change this angle to 60 degrees. So that means we're going to divide pi by 3. And now you can see that we have a height that's close to 10,000. And then now the distance is somewhere in between 20,000 and 25,000, closer to 20,000. Okay, and then let's just check and see what it would look like if it was an angle of 75 degrees. 75 degrees would be pi divided by 2.4. So here's the height. Well, the height is pretty high now here, and we can see that it lands in between 10,000 and 15,000. So what does that tell us? Well, what that tells us is that when alpha, okay, is in between 0 and 90 degrees, it increases up to 45 degrees. The projectile attains a greater height and a greater range, and as alpha increases past 45 degrees, the projectile attains a greater height, but its range decreases. And so here is the summary of our graph and what we saw with our angles using it on Desmos. So now in part C, we want to show that the path is parabolic by eliminating the parameter. So what we want to do is we're going to solve for t for x and then plug it in to y. So what we're going to do is we have the velocity times the cosine of alpha t is equal to x. And we divide both sides by the velocity cosine alpha. So we get x over the velocity of cosine alpha. So now we're going to plug that in for y. So we have y, which is equal to the velocity of sine alpha, times we have x over the velocity times cosine alpha, minus 1/2 g, and we know that again, what is t? And we need to square it. Well, the value of t is x over the velocity times a cosine alpha. And so we have y, which is equal to, we have the velocity of sine alpha divided by the velocity of cosine alpha, x, minus 1/2 g times x squared over the velocity squared cosine squared alpha. So if we want to simplify this a little further, we know that we can eliminate the velocity there. And so what we have left is sine alpha over to tangent alpha, cosine alpha is tangent alpha of x, minus, in the numerator, we're going to have g, and it's 1 times g in the numerator, and then 2 times the velocity squared times cosine squared alpha x squared. And so this is a parabola in terms of x. And so we've eliminated the parameter